Hi everybody, it's Mr. Arocena, and on today's video we're going to go over these complicated circuit diagrams from the circuit worksheet, how to solve them. So here's the first one, question 5, and the table is, okay. So we're going to use a combination of Kirchhoff's law and Ohm's law to help us figure this out. So looking at this table, seems like we're missing a lot of information, but there's some information we can immediately sort of put in. So for example, we know that the total current flows through the battery and basically all parts of that circuit. So it'll flow through this part, it'll flow through this part, it'll flow through this part, it'll actually also flow through this part. So this means then that the total current flows through R6. So we can say, okay, R6 will have a current of 2 amps flowing through it. Okay, so you can sort of see that because R6 is on the same sort of path or same, basically right after the battery. So if we treat this segment as a series circuit, that means that the current in this part of the circuit has to be the same. If it's 2 amps going through the battery, it'll be 2 amps going through R6. Alright, so using Ohm's law, we can calculate the voltage at R6 as current times resistance. This will be 4 volts. Alright, now the next part then is to figure out how much current is going to flow through each of these paths. And let's highlight that here. So how much current is flowing through here and how much current is flowing through there. And once we do that, we can then calculate R1, R2, and R3 and the values around them. So we know that Kirchhoff's voltage rule current rule states that the current going in must equal the current going out. So if I have 2.0 amps of current going in here, 2.0 amps of current must be flowing out. Now we were given here that R3 has a current of 1.5 amps going through it, so I'll write 1.5 amps here, which means then that the current in this path must be 0.5 amps, because if I add the 0.5 and then 1.5, that gets me the 2 amps that was going into it. So now I can write down R1 has a current of 0.5 amps, R2 has a current of 0.5 amps. And then using Ohm's law, I can then calculate the voltage in R1, so 0.5 times 5, this will be 2.5 volts. The current, or then I can use Ohm's law again to calculate the resistance at R2, so 3.5 divided by 0.5, that would be 7 ohms, like so. Alright, so now we've got the resistance in R1 and R2, or all the values in R1 and R2. Now, to find the voltage in R3, this one's going to be a little more difficult, so I'll leave that for now. Alright. Down to this pair, the R4, R5. Now, same idea here. If the current going into this junction is 2 amps, then this is also a 2 amp current, and then that 2 amp current will get split here. R5 has a current of 1.0 amps, which means that the current going through R4 must also be 1.0 amps. Because this current and this current to equal the current going into this junction here. Okay, now we can use Ohm's law to figure out the resistance in R4. R4 will have a resistance of, 1 divided by 4. No, sorry, 4 divided by 1. So this will be 4 ohms. Alright. R5, we don't have anything in R5. So we'll leave that for now. Alright, so we've almost figured everything out. The last thing now then is to figure out, we need to figure out one of these voltages. So I'm going to try and figure out what this voltage, total voltage is. Here we'll use Kirchhoff's voltage rule, which states that the total voltage in a circuit is going to equal all the voltages in one path. So I'm going to pick, there's one path I can pick that will have all the voltages necessary. That path is going through R1, so V1, going through R2, V2, going through R4, so V4, and then finally going through R6. That'll get me the total voltage, because that's one path. And we have all the voltages in this path because V1 is 2.5 volts, V2 is 3.5 volts, V4 is 4 volts, and V6 is also 4 volts. Calculating all this out, this is 6, this is 14 volts. So here's my total voltage is 14 volts. I can use Ohm's law to figure out the resistance. So 14 divided by 2, this will be 7 ohms. And now we can use that information to figure out the rest of it. Basically, I'm going to calculate the voltage in R3 by picking a different path that has all the voltages except for R3. And that path, let's see, total voltage, if I go through R3, let's use a different color so it doesn't get too mixed up. So R3, I know the voltage in R4, so we'll go through R4 next, and then R6 will be the last one I go through. I know my total voltage is 14 volts. V3 is what I'm trying to find. V4 I know is 4 volts, and V6 is also 4 volts. So this means then that V3, let's see, 14 minus 4 minus 4, V3 must be 6 volts. So 6 volts, and then I can do Ohm's law to calculate the resistance. So 6 divided by 1.5 is 4 ohms. Okay. And then to figure out R5, we do the same thing. We'll pick another path. Let's do that in red. So total voltage will go through R3, because we just calculated what that is, R5, and then R6. So now we get 14 is, V3 we know now is 6 volts, not 4, 6 volts. We don't know what V5 is, and we know V6 is 4 volts. Doing the math, we get an answer of, not 6, 14 minus 6 minus 4, that will be, not 8, it'll be 4 volts, equals V5. So we'll put 4 volts here, and then do the math. This will be, 4 ohms. There we go. There. So that's how we solve this one, using a combination of Ohm's law and Kirchhoff's law.